Hello and welcome to the third part of our first lesson in Unit 0 in our Grade 10 Academic Math class, Exponent Laws. So we've reviewed our exponent laws in a table above. We worked a few examples that are pretty straightforward with how to both simplify and then simplify and evaluate. This last one is just dealing with slightly more complicated applications of that. So let's start by looking at 3a. What you'll see here is we have three terms being multiplied together. We can see that because we have these brackets sort of bumping up with no numbers in between. So we're being asked to multiply these things together. It's a complicated thing to do, and my recommendation, and I've written it out here in the example, is to actually do it sort of in segments. So what I've done here is I have taken just the coefficients first, and here's the coefficient, that's the number out front. So I've done, or I recommend doing 4 times, now that's a -1 times 3. So 4 times -1 times 3, and again you can see I've written that down right there. 4 times -1 times 3, and we've sort of dealt with the coefficients now. Now let's look at the x's. So from the first term we have x to the exponent -3, then x to the exponent -2, lastly x. Now there isn't a visible exponent there, but anytime we don't see an exponent, it's going to be an exponent of 1. And that's what I've written down here, those three parts being multiplied together, and lastly the three parts of y being multiplied together. And now we just have to sort of simplify each component, which will result in a single term at the end. So with our first piece, we have 4 times -1 times 3, which gives us -12. In the second part, we have x to the exponent -3, and it's being multiplied by the other. So when we're multiplying powers with the same base, keep the base, that's the x, and then we add the exponents. So -3 plus -2 gives us -5, and -5 plus 1 gives us -4. Lastly, with the y's, we have, again, we're same base being multiplied together. We are going to add those exponents together. We have 7 plus -5, which gives us 2, and 2 plus 3 gives us 5. And you can see that's the result we have down here. Now that's fine, we have a single term. The issue is that we have a negative exponent still nestled in there. So what we want to do is deal with that. And we know how to do it, because remember, this is not just an x, this could be written as an x over 1. So we are going to invert that base, and that's going to give us 1 over x to the exponent +4, which I've done down here. Now, because we have these three terms, these three rational terms, fractions being multiplied together, as just a bit of a recall for you, we're going to multiply the numerator times the numerator times the numerator in our new resulting fraction. So -12 times 1 times y to the exponent 5 is -12y to the exponent 5 over multiplying these three guys here together to give us the denominator. So 1 times x to the exponent 4 times 1 is going to give us x to the exponent 4. And that is our final answer. So I really want to encourage you to, in your notes or in your notebook, copy down this example in particular in its entirety. This is going to be a really important way of keeping it all straight as you work through more complicated examples. Speaking of, let's go jump over to B. So here we have -2m squared n to the exponent -3 whole thing to the exponent -5. So your temptation is going to be to fix n to the exponent -3 as 1 over n to the exponent +3. And I don't recommend you do that just yet. And the reason is because right now we have all three parts of this term on the same level, so to speak. They're all part of the numerator. So if we are going to apply this -5 to each component, the -2, the m squared, and the n to the exponent -3, we should do that first. So let's work that through. I'm just going to write them out. That's going to give us -2 to the exponent -5 multiplied by m to the exponent 2 whole thing to the exponent -5 multiplied by n to the exponent -3 whole thing to the exponent -5. And now we can start to deal with some more exponent laws. Now -2 to the exponent -5, we don't have to do anything with that because there is only one sort of visible exponent that's happening at the moment. So let's just leave that guy alone. And here, however, we have a power of a power. And a power of a power, we keep the base, so it's times m to the exponent, and we're going to multiply those exponents together. So that's going to be -10. And we're going to do the same thing over here. This is another power of a power, and that's going to give us n to the exponent +15. So now we've applied some exponent laws. We're having a look at this. At this point now that we have sort of single terms being multiplied together, or single powers, now we can start to deal with those negative exponents. So we have, for a coefficient, that -5, we can get that to be a +5 if we invert our base, which I've done. And again, as I've said, it's not great to have a negative exponent down in our denominator, but we're just going to ride with it for now. We'll make sure we fix that at the end. Followed by 1 over m to the exponent 10. And interestingly enough, this one can just stay, but I am going to write it over 1, just so you can see that we have this sort of designation of numerator, 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 denominator, denominator, denominator for when we get to the multiplying step. So the last thing we want to do before we multiply through is actually evaluate wherever we can. And for our first component, the coefficient, we can do that. So here we have 1 over, now negative 2 to the exponent 5. Remember, that's just negative 2 times negative 2, which is 4, times negative 2, which is negative 8, times negative 2, which is 16, times negative 2, which is negative 32. That's what we've got going on there. This is 1 over m to the exponent 10, and this is n to the exponent 15 over 1. All right, we're rocking. So now, as we did in the other example, numerator times numerator times numerator, that's going to be our new numerator, which is n to the exponent 15, over denominator times denominator times denominator. So that's going to be negative 32 times m to the exponent 10 times 1. So that's going to be, and I'm going to write this just as 32 m to the exponent 10, and I'm going to relegate that negative out front just to sort of rep the whole fraction. And there it is. That's how we work it out. Again, a more complicated example. I'm putting in lots of steps, and I guess I should say at this point, especially with these first two examples sort of behind us now, when you see something that has a lot of steps, I really encourage you to write it out for your notes. And the notes, the reason I ask you to do it in the notes is because it's a reference. Like when your teacher's not around and you're trying to remember, how the heck did I do that? Your notes can serve as a good reminder of how it was done. That's why I also draw in things like these little arrows. I find them to be quite helpful when you're trying to remember, like, how the heck did I get to that next step? Hopefully it serves as a bit of a prompt, a bit of a reminder. All right, let's get to the last example here. So we have 2y to the exponent 4 times 8y to the exponent negative 12 all over negative 4y squared, whole thing to the exponent negative 3. So as I said in video number 2, each of these numerator and denominator sort of need to be finished before we can move on to dealing with the division. So let's work the numerator here first. Again, we're multiplying these two terms together. So I'm going to start by just multiplying these two coefficients first. So 2 times 8 is going to give us 16. Then let's look at the y's rather next. So we have y to the exponent 4 times y to the exponent negative 12. So that's going to give us y to the exponent negative 8. And that's our numerator done. Let's head to our denominator. Now recall that this negative 3, I'll sort of do it underneath because I'm out of space on top, we're going to apply that to both the negative 4 and the y squared. So let's write that out. We'll write this one out a little bit longer, I guess. So here we have negative 4 to the exponent negative 3 times y to the exponent 2 whole thing to the exponent negative 3. So we worked it out. At this point, we are going to just start to evaluate some of the numbers in the bottom, in our denominator, because our numerator is kind of just rocking there. It's just kind of doing its thing. Let's work through the rest of the denominator. So that's 16y to the exponent negative 8. We'll deal with that negative 8 shortly. And here we have negative 4 to the exponent negative 3. So I'm going to deal with that by writing that as 1 over negative 4 to the exponent positive 3 times y to the exponent negative 6. So again, we require a little bit more work here because that negative in our denominator needs to be dealt with. But I would recommend at this point that we just evaluate the 1 over negative 4 to the exponent 3. And you'll see why in a second. So here we have 16 y to the exponent negative 8 all over. So we have 4 times 4 times 4, which is, or rather negative 4 times negative 4 times negative 4, which is negative 64. And there's our y to the exponent negative 6. So what I'm going to do next is I'm going to sort of draw this out. Sorry, getting calls from Japan. No need for that now. We are going to write this out in a slightly different way. So I want you to remember that each of these components is kind of its own little thing. And what I mean by that is I can write this as 16 over 1 and kind of just put brackets around it and leave it alone. And I'm just rewriting this little piece right here. Similarly, I can write 1, whoops, that's a highlighter. I can write this as 1 over negative 64. That's the other component of the coefficients. I can write this as y to the exponent negative 8 over 1. And I can write this as 1 over y to the exponent negative 6. All I've done is taken all four what I would call components, I guess, of the numerator and the denominator, and I've kind of spread them out and written them out. Because now this is going to make it a little bit easier to deal with the things we have going on. So I'm going to do a little shout out over here. So I want you to see that there is a little shortcut that we can work through. So if we have this over here, and I'm referring to this piece right here, this is 1 divided by 1 over negative 64. And if you remember dividing fractions, you can write that as 1 times the inverse of that. This is, I think we call it KCI from your grade 9 class, which is keep the first fraction, change division to multiplication, and then invert the last fraction. So we have 1 times negative 64 over 1, which is going to give us just negative 64. So what's interesting about that is if we look at our patterning, we have here 16 over 1 times negative 64 over 1. And we know how to deal with our negative exponents here. We're going to write that as 1 over y to the exponent positive 8. And we know, interestingly enough, we haven't done this yet, but if you have a negative in the denominator, it works the same, our negative exponent in the denominator, it works in the same way. So if I invert 1 over y, I end back up with y times y to the exponent positive 6 over 1. And now here I have a nice opportunity to multiply numerator by numerator by numerator, which I'm going to do. So I have 16 times 64, times negative 64 times y to the exponent 6, and that's going to, oh, that's a highlighter still. That's going to give us negative 1024 y to the exponent 6 all over denominator times denominator times denominator times denominator, which is going to give us y to the exponent 8. Last step here, we have to deal with these pesky y's. We haven't really simplified them yet. So let's get that done. We have negative 1024. And here we have y to the exponent 6 divided by y to the exponent 8. I'll just sort of do a little shout out for that too. Y to the exponent 6, y to the exponent 8. That's going to give us out over here y to the exponent 6 minus 8, which is going to give us y to the exponent negative 2. So we have negative 1024 times y to the exponent negative 2. How do we deal with that negative 2? We are going to invert the base. So negative 1024 all over y to the exponent positive 2. So that is a fairly lengthy one, lots to sort of deal with in there and unpack. Again, there's a few different ways that you can do it. We might have taken a slightly longer route, but I wanted to show you that no matter how long the route, as long as you're following the rules of the exponent laws, you're going to make it to the end without any troubles. So this is the end of the first lesson, exponent laws. What you'll notice here is that without a calculator, you're being asked to complete the worksheet on the next page. The letters listed right there, they correspond to what you're going to see on the worksheet itself. Good luck. If you have any questions, please feel free to email me, and I'll be happy to put some solutions up either in video form or provide you with some advice via email. And yeah, that's it. Good luck. We'll see you in the second lesson. Yeah.